Okay, let's dive right into this, brothers. I know exactly how messy and frustrating it gets when your belt filter press starts acting up mid-shift, right? One minute you're making this beautiful, great cake, and literally the next, alarms are blaring and you've got wet sludge all over the plant floor. It's a nightmare. So in today's explainer, we're walking systematically through standard operating procedure number 26. We are going to get that slipping, misaligned belt back in line, and most importantly, keep it there. We've got a really clear step-by-step game plan today. First, the anatomy of the press. Second, spotting the slippage. Third, finding the root cause. Fourth, executing the fix. Fifth, long-term prevention. And finally, tracking your success.
Section 1. Anatomy of the press, the baseline for success.
Okay, so your press essentially uses two synthetic fabric belts to squeeze sludge that's been perfectly mixed with a cationic polymer, through three crucial zones. First up is the gravity drainage zone. This is where the free water just simply falls away. Next, it enters the wedge zone for a gentle preliminary squeeze. And finally, it hits the high-pressure shear zone, weaving through multiple rollers for maximum dewatering. Now, if any single part of this mechanical journey is off balance, your belt is going to wander.
When those three zones are working in perfect harmony and your belt wash and tensions are totally dialed in, you should be consistently generating a solid sludge cake. Your target moisture here is exactly 75 to 82%. Honestly, that is the sweet spot. It tells you the machine is happy and functioning right at its design capacity.
Section 2. Spotting the slippage. When things go wrong. Listen up, brothers. Early detection is absolutely everything here. If you can see the belt veering off to one side with the naked eye, if you hear metal-on-metal squeaking, or if you get tracking sensor and overload alarms in your control panel, you have a slippage event happening right now. You might even notice wrinkled or folded belt edges just aggressively rubbing hard against the steel frame. Do not ignore these signs. They only get worse, and they can permanently destroy a highly expensive synthetic belt.
Another massive red flag during a slippage event is your sludge moisture just shooting right past 85%. When you start seeing this wet, sloppy mush on the belt, it basically means your dewatering process has entirely failed. You are no longer forming a solid cake, you're literally just pushing wet sludge around, wasting valuable polymer, and running up your disposal costs. No good.
Section 3. Finding the root cause. The diagnostic funnel.
First things first, we check our chemistry. Why? Because mechanical fixes will not solve bad sludge. Your polymer concentration absolutely must be between 0.1 and 0.5%. If your mix is wrong, the sludge just won't flocculate properly. It stays wet, it stays loose, and it acts almost like a lubricant, causing the sludge to just slide right off the edges of the belt and taking the belt's alignment down right along with it.
Now, before we even think about opening up the machine to inspect mechanicals like rollers and bearings, you absolutely must execute strict lockout/tagout procedures. LOTO. I literally cannot stress this enough. Turn off the main electrical and control power, padlock it, and hang your tack. We are keeping ourselves safe from massive moving parts here. Never, ever skip this step. So, with the machine safely locked out, the crucial point is checking these 4 mechanical fail points. First, grab a straight edge. If you have an alignment variance over 10 millimeters from the frame, that is bad news. Second, check your tension. A difference of more than 15% between the left and right sides will absolutely pull that belt off center. Third, measure your roller concentricity. Any deviation over 2 millimeters means you've got a bent or warped roller. And finally, check your wash system. If your pressure isn't sitting between 4 and 8 bar, your nozzles are likely clogged. That leaves heavy, wet sludge on one side of the belt which, you guessed it, causes it to slip.
Section 4. Executing the fix. Step-by-step SOP.
All right, here is our action plan. Step 1, lock it out and clean up the mess. Step 2, square up those head and tail pulleys and adjust your steering roller. Step 3, dial in your pneumatic or hydraulic tension. Step 4, run a quick 500 milliliter jar test right there at the site to fix your polymer mix. And Step 5, take a stiff brush, scrub out those clogged drainage grooves on the perforated rollers, and clear out your wash nozzles. When you're adjusting the pneumatic tension, you really want to hit the manufacturer's sweet spot. For most industrial presses, this is usually exactly 50 to 70 newtons per centimeter, and you have to ensure this tension is evenly distributed on both sides. If you over-tighten it, you're going to stretch and ruin the belt way prematurely. But if it's too loose, you're going right back to slipping. When squaring up the machine, precision is key.
Your belt edge must sit perfectly parallel to the frame with a maximum deviation of plus or minus 5 millimeters on both sides. Use a ruler or a straight edge for this. Seriously, don't just eyeball it. Getting this alignment within that strict 5 millimeter tolerance is exactly what guarantees the belt tracks straight when you turn the power back on.
Section 5. Long-term prevention. Keeping it running.
Stick to this prevention timeline, brothers. Every single shift, you need to be cleaning out those roller drainage grooves. It gets overlooked all the time, but it's incredibly important for even weight distribution. Weekly, do your polymer jar tests and check that belt alignment. Monthly, inspect your rollers to make sure wear is less than 2 millimeters. Every 500 operating hours, get in there with some water-resistant lithium complex grease for your bearings. And finally, you want to plan your budget and schedule for a completely new belt every 1,000 to 3,000 hours, depending on your plant's specific wear.
Section 6. Tracking your success. The 16-8-hour goal.
We use this exact monitoring table to make sure we stay on track. Every shift, you're verifying that misalignment is under 5 millimeters and moisture is below 82%. Every week, double-check that your tension is sitting perfectly at 50 to 70 newtons per centimeter, and monthly, verify that your bearing temperatures remain below 60 degrees Celsius after a 15-minute run.
You have to log these exact metrics meticulously in your shift record. Fill up the date, the belt variance in millimeters, your tension, your sludge moisture, your exact polymer dose, and note any alarms. If you don't track the variance in the polymer dose over time, you are basically flying blind. And I guarantee you won't see the next slip coming until sludge is already on the floor again.
According to SOP 26, the ultimate benchmark of a genuinely successful repair is hitting 168 continuous hours. That's a full 7 days of operation with absolutely straight belts, 0 tracking alarms, perfectly dry cake, and a clean, dry plant floor. If you hit 168 hours, you haven't just patched the problem, you've actually solved it.
So, brothers, I want to leave you with this provocative thought to consider before you clock in for your next shift. Look really closely at how you operate. Is your daily maintenance routine, your cleaning, your jar tests, your visual checks, truly preventing the next slip? Or are you kind of just crossing your fingers, skipping the small details, and waiting for those alarms to sound again? Take control of the machine, follow the SOP, and keep that plant running smoothly.